Close your eyes for a second. Actually, don't close your eyes. You need to watch this. But I want you to picture something. Picture the most peaceful evening sky you have ever seen. Maybe you were out on your porch. Maybe you were sitting in your backyard. Maybe you were just walking to your car after a long day. And you looked up, and you saw it. That one star that is always a little bit brighter than the rest. The one that does not twinkle like the others do. The one that just glows, steady and perfect, near the horizon just after the sun goes down. You have seen it your entire life. Billions of people on Earth look up at that light every single night. That light is Venus. And I need you to understand something about Venus right now, before we go anywhere else in this video. That beautiful, peaceful, glowing light in your evening sky is sitting on top of the most hostile, violent, and unforgiving surface that exists anywhere in our solar system. The thing that looks like the most gentle star in the sky is a planet where the air itself is poisonous, where the ground temperature never drops below 800 degrees, where the atmospheric pressure would crush your body before you had time to register what was happening, and where the clouds, those gorgeous white clouds that make it shine so brightly, are made of concentrated sulfuric acid, and all of that is happening right now. Tonight, while you are sitting here watching this video, Venus does not care. Venus has never cared. Venus has been this way for billions of years, hanging in the sky looking beautiful, hiding a truth that would take humanity centuries to even begin to understand. Today we are going to understand it. This is not going to be a quick video. I want to be upfront with you about that right now. Because what I am about to take you through is not something that can be rushed. We are going to spend the next hour on Venus, going through the science, the history, the exploration, the mysteries, and what this planet is actually trying to tell us about our own world. By the time we are done, you are going to know Venus in a way that most people who have ever lived never got the chance to. So if you have been looking for something worth your full attention tonight, this is it. And before we go any further, if you are new here, welcome to Brain Twist. This channel exists for people who want to actually understand the universe, not just scroll past it. Hit that subscribe button right now, because the kind of deep dive content we are about to get into is exactly what this channel does every single week. You are going to want to be here for what comes next. Now, let's go to Venus. Let's start at the beginning. Not the beginning of Venus. The beginning of how humans thought about Venus. Because the story of how wrong we were about this planet for so long is one of the most fascinating chapters in the history of science. For most of human history, Venus was not understood as a planet at all. Ancient civilizations saw it as a star, the brightest star in the sky, and they built entire mythologies around it. The Babylonians tracked it with remarkable precision. They recorded its movements in clay tablets more than 3,000 years ago, calling it the Queen of Heaven. The ancient Mayans built their entire calendar system partly around the cycles of Venus. The Greeks thought it was two different stars. Phosphorus, when it appeared in the morning sky before sunrise, and Hesperus, when it appeared in the evening sky after sunset. It took a surprisingly long time for ancient astronomers to realize those two lights were the same object. The Romans eventually named it Venus, after their goddess of love and beauty, and that name says everything about what humans thought of this planet for the vast majority of our history. It was associated with beauty, with femininity, with the most pleasant things in human experience. And why not? Look at it. It is objectively gorgeous. Even through the earliest telescopes, Venus presented itself as something almost magical. When Galileo first turned a telescope toward it in 1610. He discovered it had phases. Like the Moon, Venus went through a cycle from crescent to full as it moved in its orbit. This was actually one of the key pieces of evidence that confirmed the Earth moved around the Sun, rather than everything moving around the Earth. Venus's phases only made sense in a solar-centered model, but Galileo could not see the surface. Nobody could, and that was the beginning of a centuries-long guessing game. Because here is the thing about Venus through a telescope, it is completely blank. There are no surface features visible, no dark patches like you can see on Mars, no distinctive markings, just a uniform, perfect, pale disk. Those clouds, the sulfuric acid clouds, cover the planet absolutely and completely. From the outside, Venus gives you nothing. It reveals nothing about itself. And so scientists speculated, through the 1700s and 1800s and into the early 1900s. The dominant scientific theory about Venus was that it was a warm, wet, tropical world. The reasoning seemed logical. Venus is closer to the Sun than Earth, so it receives more solar energy. The clouds suggested moisture. And the complete lack of visible surface features meant you could imagine whatever you wanted underneath. Serious scientists proposed that Venus might be covered in vast, shallow swamps. Others suggested dense jungles extending from pole to pole. Some imagined vast oceans of warm carbonated water. There were papers published in respected scientific journals describing Venus as Earth's twin. A younger, more primitive version of our world, teeming with simple plant life. Even into the 1950s, science fiction was filled with Venus-set stories featuring lush alien jungles, intelligent civilizations, and oceans stretching horizon to horizon. The scientific community was not unanimous on this. There were dissenting voices. Researchers who pointed out the lack of evidence for water vapor in the spectrum of light coming from Venus, but the romantic idea of a twin Earth hidden beneath those clouds was powerful, and it persisted. Then came 1962. And a spacecraft the size of a large refrigerator changed everything. Mariner 2 was the first successful interplanetary spacecraft in history. Launched by NASA in August of 1962, it flew past Venus on December 14th of that year, coming within 21,000 miles of the planet. It carried instruments to measure temperature, magnetic fields, and atmospheric composition. And what it found, in a single flyby, shattered everything scientists had imagined for 300 years. Venus was not warm and tropical. The surface was not covered in swamps and jungles. The temperature readings coming back from Mariner 2 indicated surface temperatures approaching 500 degrees Celsius. The atmosphere was found to be primarily carbon dioxide. There was no detectable magnetic field of significance. The dream of a twin Earth died in December 1962. What replaced it was something nobody had been prepared for. A world that had turned itself into a furnace, and that was going to take everything humanity had to even begin to understand. Let me give you the numbers. Because numbers are where this gets real. The surface temperature of Venus is 967 degrees Fahrenheit. That is 465 degrees Celsius. I am going to give you some reference points for that temperature, so it actually lands in your brain, rather than just being an abstract number. Water boils at 212 degrees Fahrenheit. The surface of Venus is more than 4 times that temperature. A standard kitchen oven, running at its maximum setting, tops out at around 550 degrees Fahrenheit. The surface of Venus is hotter than that. The melting point of lead, the dense, heavy metal, is 621 degrees Fahrenheit. If you placed a block of lead on the surface of Venus, it would melt. Not slowly over hours. It would become liquid within minutes. Zinc melts at 787 degrees Fahrenheit, still below Venus surface temperature. Tin melts at 449. Aluminum melts at 220. That one would survive Venus. But almost every common metal that humans use in everyday life would not. The temperature inside a commercial pizza oven used to cook Neapolitan pizza is around 800 to 900 degrees Fahrenheit. The surface of Venus is in that range, the range where professional pizza ovens operate. And here is the part that genuinely gets to people when they first hear it, that temperature never changes. On Earth, we have day and night. Temperatures drop when the sun goes down. We have seasons. We have weather systems that move heat around. The difference between the hottest place on Earth and the coldest place is enormous. From the frozen interior of Antarctica, at around negative 128 degrees Fahrenheit to the furnace heat of Death Valley in summer, the range is about 260 degrees across our entire planet. Venus has almost no temperature variation. The side facing the sun is 167 degrees. The side facing away from the sun is 147 degrees. 20 degrees of difference across an entire planet, day and night, pole to equator. Surface everywhere. Venus is essentially a uniform furnace. The reason for this is the atmosphere. Venus's atmosphere is so thick and so dense that it distributes heat around the entire planet before any location can cool down. The CO2 atmosphere traps heat so effectively that even the night side, which is in complete darkness, never cools below temperatures that would melt lead. Now let's talk about that atmosphere in more detail, because the temperature is only one part of what makes Venus extraordinary. The surface atmospheric pressure on Venus is 92 times the atmospheric pressure you experience right now, wherever you are sitting. 92 times. The way to visualize this is to think about what happens to pressure as you go underwater. Every 33 feet of depth in the ocean adds roughly one additional atmosphere of pressure. To experience the same pressure as the surface of Venus, you would need to descend to approximately 3,000 feet below the surface of the ocean. 3,000 feet. That is nearly 3 times the depth at which recreational scuba divers are advised never to exceed. It is deeper than most nuclear submarines are rated to operate. At that depth in Earth's ocean, the pressure is enough to crush most everyday objects, implode hollow spaces, and kill a human being very quickly if they were unprotected. That is what the entire surface of Venus feels like. Not just at one specific depth. Everywhere, at all times, on every square foot of the planetary surface. The submarines that military navies use can handle pressures down to roughly 500 to 700 meters. Let's call it 600 to 300 feet of depth. The engineering to build vessels that survive those pressures is extraordinary. Thick steel hulls, carefully managed internal pressure. Years of development. Even those submarines would be immediately crushed on the surface of Venus. Now add the composition of that atmosphere on top of the pressure. The atmosphere of Venus is 96.5% carbon dioxide. On Earth, our atmosphere is 78% nitrogen and 21% oxygen. Carbon dioxide, the gas that powers the greenhouse effect, the gas that plants absorb during photosynthesis, the gas that your body exhales, makes up just 0.04% of Earth's atmosphere. On Venus it is 96.5%. You cannot breathe carbon dioxide. Your body has no mechanism for extracting oxygen from it. And at the concentrations present on Venus, combined with the pressure and temperature, the CO2 atmosphere becomes something genuinely strange from a physics perspective. At Venus surface conditions, above 87 degrees Fahrenheit and above 73 times atmospheric pressure, carbon dioxide crosses into what scientists call a supercritical state. It stops behaving clearly as either a gas or a liquid. It has the density of a liquid and the flow characteristics of a gas simultaneously. On the surface of Venus, you would not be standing in air. You would be standing in something more like an incredibly hot, incredibly dense, reactive fluid that happens to be transparent. The experience would be unlike anything humans have encountered anywhere on Earth. And then there are the clouds. The clouds of Venus exist in three distinct layers, between roughly 28 miles and 43 miles above the surface. They are composed primarily of droplets of sulfuric acid, H2SO4, at concentrations of roughly 75 to 96%. Concentrated sulfuric acid at that strength is extraordinarily corrosive. It reacts violently with organic tissue, with most metals, with water, with a large number of common materials. On Earth, concentrated sulfuric acid is one of the most carefully handled industrial chemicals. It is used in battery manufacturing, in petroleum refining, in chemical synthesis. It is transported in specially lined tanker trucks. A spill of concentrated sulfuric acid is a serious industrial emergency. On Venus, concentrated sulfuric acid falls from the sky. It does not reach the ground. The droplets evaporate in the extreme heat of the lower atmosphere before they get there, and the sulfur compounds recycle back upward. But throughout the cloud layer, any spacecraft passing through it is being continuously bathed in sulfuric acid chemistry. Any material exposed to those clouds is being slowly chemically attacked. The clouds also affect the planet's surface in another way. Because they are so thick and so reflective, they bounce about 70% of the sunlight that hits Venus back into space. Venus actually absorbs less solar energy than Earth does, despite being closer to the Sun. The sunlight that does get through is quickly trapped by the CO2 greenhouse effect. But the initial reflection means Venus is actually quite shiny, which is precisely why it looks so brilliant from Earth. The beauty you see in the night sky is, in large part, the reflection of our own Sun's light off a global ocean of sulfuric acid clouds. Now I want to tell you about the most extraordinary and underappreciated space program in human history. Most people, when they think about the space race of the 1960s and 1970s, think about the moon. America won the race to put humans on the moon. That story is well known. But while NASA was focused on the moon, the Soviet Union made a decision that the Americans were not making. They were going to conquer Venus. Not metaphorically. They literally attempted to send working spacecraft to the surface of Venus and have them operate there. They tried this repeatedly, over more than 2 decades, in what became known as the Venera program. Named from the Russian word for Venus, the Venera program began in 1961 and ran through 1984. Over that time, the Soviet Space Agency launched 28 spacecraft toward Venus. Not all of them reached their target. Not all of them worked correctly. But many of them did things that no human technology had ever done before. And the engineering story of how they pulled it off is one of the most remarkable chapters in the history of human scientific achievement. The first challenge was simply getting to Venus. Interplanetary trajectories are enormously complex. The spacecraft has to be launched at precisely the right moment, with precisely the right velocity, and follow a carefully calculated curved path that accounts for both Earth's movement and Venus's movement over the several months the journey takes. Getting this wrong means missing the planet entirely. Early Soviet Venus missions failed in various ways. Launch failures, communication failures, spacecraft systems that did not survive the journey. But the Soviets kept trying. In 1967, Venera 4 became the first spacecraft to successfully enter the Venus atmosphere and transmit data back during its descent. It returned measurements confirming the atmosphere was primarily carbon dioxide and recording temperatures that were even higher than some scientists had expected. The spacecraft transmitted for 93 minutes before falling silent. Scientists initially thought it had reached the surface, but later analysis suggested the pressure had destroyed it before it got there. The atmosphere was even denser than they had modeled. The next 2 missions, Venera 5 and Venera 6, were designed with that in mind. They were built stronger, capable of surviving higher pressures. But Venus still won. Both spacecraft were crushed by the atmosphere before they reached the surface. Then came Venera 7 in 1970. The Soviets had completely redesigned their approach. They built the pressure vessel, the shell containing the instrument package, out of titanium, capable of withstanding pressure of 180 atmospheres. They figured if Venus was going to crush them, they would build something that could survive twice the pressure they expected to encounter. They were almost right. Venera 7 reached the surface of Venus on December 15, 1970. It was the first spacecraft in human history to land on another planet and transmit data from the surface. The data it sent back was partial. The spacecraft had been damaged during descent and landed at an odd angle, and only a portion of the signal made it through. But the transmission lasted for 23 minutes. 23 minutes of data from the actual surface of Venus. At the time, it was the most extraordinary thing humanity had ever accomplished in space exploration, outside of walking on the moon. Temperature reading from the surface 87 degrees Fahrenheit. Atmospheric pressure approximately 90 times Earth's. Exactly as hostile as feared, or worse. The Soviets did not stop there. Venera 8, 9, 10, 11, 12. Each mission improved on the last. The engineering kept evolving. The spacecraft were getting better at surviving. And then came what I consider the crown jewel of the entire program. Venera 13 and Venera 14, launched in late 1981. Venera 13 landed on Venus on March 1, 1982. It was a masterpiece of Soviet engineering. The lander was a squat, heavily armored cylinder sitting on a ring-shaped landing platform, with spring-loaded shock absorbers to cushion the impact. It was packed with scientific instruments. It had cameras. It had a drilling arm that could sample the rock beneath it. It was designed to function in hell, and it was built by people who knew exactly how bad Venus was and built it anyway. Venera 13 survived on the surface for 127 minutes. 2 hours and 7 minutes. That is the longest any human-made object has ever survived on the surface of Venus. In that time, it transmitted color photographs of the surface. The first color images ever taken on another planet. And it drilled into the Venusian rock and analyzed the composition. The photographs are extraordinary. You can find them. They show a rocky landscape, dark basaltic slabs stretching in every direction, the horizon close and hazy, the sky a dull orange. It looks like the inside of a furnace that has been running long enough to bake everything to the same dull color. There is nothing moving. There is no wind visible in the images. It is perfectly, utterly still. And in the background of those photographs, you can see pieces of the spacecraft itself, the camera housing, the landing ring, the rock samples it analyzed. Human engineering, sitting on the surface of the most hostile world in the solar system, sending images back across 90 million miles of space for 2 hours and 7 minutes. Then Venera 13 fell silent. Venus 1. Venera 14 landed 4 days later and survived for 57 minutes. Also extraordinary by any standard other than its own sibling. No mission since has survived longer. No subsequent spacecraft has landed on Venus. We have sent orbiters, we have flown past, but nothing has landed since the Venera program ended. For 40 years, the surface of Venus has been left to itself. The Venera images remain the only photographs ever taken on the surface of Venus. 40 years old. Still unmatched, still the only window we have ever had into that world. This is the part that people always want to know. And I want to give you a real answer. Not a sensationalized version, not a Hollywood version, but an accurate scientific account of what would actually happen to a human body in the Venus environment. To be clear, there is no scenario in which a human survives any contact with the Venus surface without complete engineering protection. This is not a question of fitness or toughness or willpower. The conditions are so far outside the range of human survivability that no biological adaptations, no training, no preparation of any kind changes the outcome. The question is only what specific physical processes would end a human life, and in what order. Let's walk through it carefully. First, consider what happens the moment an unprotected human being materializes on the Venus surface. Whatever the mechanism, just instantly appearing there. In the first fraction of a second, 3 simultaneous processes begin that each alone would be immediately fatal. The atmospheric pressure, 92 times Earth normal, would impact every structure in the human body simultaneously. Hollow spaces are the most vulnerable. The lungs, the sinuses, the internal cavities. These exist at near Earth pressures inside the body, and the pressure differential between inside and outside would be catastrophic. The body would not be simply squashed from outside. The compression would be more complex than that. Internal organs displaced by the sudden pressure shift. The cardiovascular system encountering a pressure environment, it has no mechanism to accommodate. Blood vessels experiencing forces they cannot structurally manage. Simultaneously, the thermal environment, 867 degrees Fahrenheit, would begin transferring heat into the body. Human tissue begins to denature, to break down structurally at the molecular level. At temperatures well below boiling, the protein structures that make up muscle, connective tissue, and organ walls become unstable. At Venus surface temperatures, this process is not slow. The thermal energy being transferred into the body would be extraordinary. And simultaneously, the atmospheric composition, 96.5% CO2, means that no oxygen is being delivered to any part of the body through any respiratory mechanism. The CO2 itself, at those concentrations and pressures, would have its own direct physiological effects on blood chemistry, on cellular function, on neurological activity. The honest scientific answer to which of these kills you first is that the question does not quite work the way it sounds. It implies a sequence where one thing happens, then another, then another. The actual process is simultaneous. All 3 mechanisms are acting on the body at the same moment, from the first instant of exposure. If forced to rank which system would fail first in terms of producing unconsciousness, and therefore the end of the person's experience, the thermal shock would be extraordinary. The pressure effects would be immediate, but the cardiovascular and neurological disruption from the combined pressure and atmospheric chemistry would likely produce loss of consciousness within seconds. Perhaps 1 to 3 seconds at most. The suffering that people imagine when they think about dying on Venus, the prolonged experience of extreme conditions, would not occur. The experience would end almost immediately. What continued afterward would be a physical and chemical process, not a conscious experience. I want to be very precise here, because this is a scientific explanation and not an attempt to be dramatic. The reason these conditions are so extreme is precisely because they are so far outside any range that biological life on Earth is adapted to handle. Earth life, including humans, evolved in a very specific pressure, temperature, and atmospheric composition window. Venus's surface sits so far outside that window that the body simply has no mechanisms to respond to it. It is not like drowning, where there is a period of distress and struggle. It is much faster than that. What makes Venus genuinely haunting is not the experience of dying there, which would be mercifully brief, but rather the absolute indifference of the environment. Venus does not want to kill you. It simply is what it is. The same conditions that would end a human life in seconds have been continuous and stable for hundreds of millions of years. You are not special to Venus. You are simply another thing that cannot survive there. The same thing that happened to the Venera spacecraft would happen to you. The planet processes everything the same way, with total, quiet, ancient efficiency. The Venera 13 spacecraft was built by the best aerospace engineers the Soviet Union had. It was built specifically to survive Venus. It was their best effort. And it lasted 2 hours. You would not last 2 hours. Okay. Stop for a second. I know you have been watching for 30 minutes. And I know that attention is the most valuable thing you have right now. You could be doing literally anything else. So let me tell you what is coming in the next 30 minutes, because I promise you it is worth staying for. We have talked about what Venus is. We have talked about what it would do to you. We have talked about the most extraordinary robot missions in human history. But we have not talked about the thing that genuinely keeps scientists up at night. We have not talked about the floating city. We have not talked about the gas that should not exist in Venus's atmosphere, but does. The gas that, on Earth, is almost exclusively produced by one thing. We have not talked about what Venus is actually trying to warn us about. A warning that is written in 4 billion years of planetary history, and that is aimed directly at us. And we have not talked about what scientists believe Venus looked like before everything went wrong. What it might have been. What it might have been capable of supporting. That is all coming. And if the first half of this video shook something loose in your understanding of our solar system, the second half is going to make it feel personal. One more thing before we continue. If you have made it 30 minutes into this video, and you have not subscribed to Brain Twist yet, I genuinely do not understand what you are waiting for. This is what this channel does. Every week. Deep, serious, careful exploration of the things in this universe that deserve more than a 60-second clip. Hit subscribe right now. It costs you nothing, and it means you will not miss what comes next on this channel. Because what is coming next is going to be even bigger than this. Alright, let's keep going. Here is something that I want you to hold in your mind as we go into this section. Everything we have talked about so far, the crushing pressure, the furnace heat, the sulfuric acid clouds, the CO2 atmosphere, all of that is true of the surface of Venus and the lower atmosphere of Venus. But Venus is not just its surface. Venus is a planet. And like all planets, it has layers of atmosphere at different altitudes. And as altitude increases, pressure drops and temperature drops. That is basic atmospheric physics. The same reason it is cooler at the top of a mountain than at the bottom. Now watch what happens when you apply that to Venus. At the surface of Venus, 167 degrees Fahrenheit, 92 atmospheres of pressure. Immediate death for anything biological. Instant destruction for most engineering materials. The worst place in the solar system. At 10 miles above the Venus surface, still extremely hot, still far above human survivability, still extremely high pressure. Equally deadly. At 20 miles above the surface, conditions are improving, but still nowhere near manageable. The lower cloud deck is here. Sulfuric acid chemistry is active. Still fatal. At 30 miles above the surface, something changes. At approximately 31 miles altitude above the Venus surface, roughly 50 kilometers up, the temperature of the atmosphere is between 86 degrees Fahrenheit and 158 degrees Fahrenheit. That is a range that includes a hot summer day in Phoenix, Arizona, on the low end, and a temperature that would give you a very serious fever on the high end. Uncomfortable. Potentially dangerous with prolonged exposure, but survivable by a human being with appropriate protection. The same kind of protection an astronaut working outside the International Space Station already uses for thermal management. The atmospheric pressure at that altitude is approximately equal to Earth's atmospheric pressure at sea level. Read that again. The pressure at 31 miles above Venus is roughly equal to the pressure you are experiencing right now, sitting wherever you are. It is the same pressure. You are already adapted to it. Your cardiovascular system already handles it perfectly. And at that altitude, Venus is close enough to the Sun that solar power works extraordinarily well. The sunlight hitting the upper cloud tops of Venus is actually more intense than the sunlight hitting Earth's surface, because Venus is closer to the Sun. A solar-powered vehicle at that altitude would have an abundant, reliable energy source. And the atmosphere itself, primarily CO2, is actually buoyant relative to the nitrogen and oxygen mixture that humans breathe. A habitat filled with Earth, normal air would float in the Venus atmosphere, at that altitude the same way a helium balloon floats in Earth's atmosphere. The physics works naturally, without exotic engineering. A sealed habitat with Earth, like air inside it, would have positive buoyancy in the Venusian atmosphere at that altitude. It would float there without any active lift system. This is not science fiction. This is basic atmospheric physics applied to real Venus data. In 2014, a team of NASA engineers published a concept study called HAVOC, the High Altitude Venus Operational Concept. They laid out in serious technical detail what a crewed mission to the Venus upper atmosphere might actually look like. Not a surface landing, not a flyby. A crewed mission where human beings would live and work inside a large airship floating in the Venus cloud layer at 31 miles altitude. The HAVOC concept involves a vehicle roughly the size of a large commercial aircraft, enclosed in a sealed pressurized habitat, with solar panels extending from the top. The airship would be made from materials capable of resisting the sulfuric acid chemistry present even at that altitude. Because while the conditions are survivable, the sulfuric acid clouds are still present at 31 miles, and any exterior materials would need to be acid resistant. Teflon, coated fabrics and certain polymers can handle this chemistry. Astronauts would live inside a pressurized module at Earth, like conditions: normal air, normal pressure, normal temperatures managed by the habitat systems. The exterior of the vehicle would handle the Venus environment, so the interior did not have to. The mission architecture that NASA engineers proposed would start with robotic airship missions to demonstrate the technology, followed by short crewed missions of 30 days, eventually building toward longer duration stays and potentially a permanent floating station. A permanent floating station in the atmosphere of Venus. Think about what that actually means. Not just as a scientific achievement. Think about it as a place. A human outpost floating above the clouds of the most hostile planet in the solar system. Humans sitting inside a pressurized airship, looking out through the windows at an orange sky, knowing that 31 miles below them the surface is covered in molten metal, temperature rock under 92 atmospheres of pressure, and that they are floating above it safely, doing science, living their lives. It is one of the most genuinely extraordinary concepts that has come out of serious aerospace engineering in the past 20 years, and almost nobody knows it exists. Now here is the comparison that I think reframes how you think about the future of human space exploration. When people talk about where humans should go next, Mars is the obvious answer. Mars is the plan. Multiple space agencies and private companies are actively working toward crewed Mars missions. Mars has become the default answer to the question of where humanity goes after the Moon. But the upper atmosphere of Venus, by several specific measures, is actually more hospitable to human presence than the surface of Mars. On Mars, the atmospheric pressure is less than 1% of Earth's. You cannot breathe outside your habitat. You cannot survive outside your habitat without a full pressure suit. The temperature on Mars ranges from roughly -220 degrees Fahrenheit at the poles in winter to about 70 degrees Fahrenheit at the equator on a summer afternoon. A brutal range that requires careful thermal management. Mars receives significantly less sunlight than Earth or Venus, making solar power less effective. The Martian surface is also covered in fine dust that contains perchlorates, toxic chemical compounds that pose health risks. The Venus upper atmosphere, by contrast, has pressure equivalent to Earth's. It has sunlight equivalent to, or greater than Earth's. It has temperatures within the range that human engineering can manage. The only significant challenge that Venus presents at that altitude that Mars does not is the sulfuric acid chemistry in the exterior environment, and the fact that there is no solid surface to land on. Both of those are engineering problems. Difficult ones, but the kind that the aerospace industry has experienced solving. This is not an argument that Venus is easy. Nothing about Venus is easy. But the HAVOC concept reveals something important. Our solar system contains a location that has been completely ignored in human space exploration planning, that sits closer to Earth than Mars, that receives more reliable sunlight than Mars, and that has atmospheric pressure essentially identical to Earth's. And that location is the upper atmosphere of Venus. The most terrifying planet in the solar system has a habitable zone. Nobody told you that. Now you know. In September 2020, a paper was published in the journal Nature Astronomy that caused one of the most significant controversies in the history of planetary science. A team of astronomers led by Jane Graves of Cardiff University announced that they had detected phosphine in the atmosphere of Venus. Phosphine, pH 3, a molecule consisting of one phosphorus atom bonded to 3 hydrogen atoms. If you do not immediately understand why that announcement caused such extraordinary excitement and controversy, let me explain. Phosphine is not a stable molecule in the atmosphere of a rocky planet. It reacts with oxygen and other atmospheric compounds and breaks down relatively quickly. For phosphine to be present in detectable quantities in a planetary atmosphere, something has to be continuously producing it. Something has to be generating fresh phosphine at a rate fast enough to replace what is being destroyed by atmospheric chemistry. On Earth, phosphine is produced by 2 main sources. First, industrial chemical processes. Certain manufacturing operations generate phosphine as a byproduct. Second, and much more significantly, biological life. Specifically, microbial life in oxygen-depleted environments, swamps, wetlands, animal intestinal tracts, decomposing organic matter in anoxic conditions. On Earth, whenever you detect phosphine in a natural environment, you are almost certainly detecting the metabolic byproduct of microorganisms. The detection of phosphine in Venus's atmosphere at approximately 34 miles altitude, which sits right at the edge of the altitude range where conditions are relatively manageable, immediately raised an obvious question. If phosphine needs something to continuously produce it, and if the known non-biological chemistry of the Venus atmosphere cannot generate it in the detected quantities, then what is generating it? The scientific community did not run to any dramatic conclusion. That is not how science works. And the researchers themselves were careful to note that they were reporting an observation and proposing the need for follow-up investigation, not claiming to have found life. But they also did not dismiss the biological hypothesis. They went through the known non-biological chemistry of Venus systematically. Volcanic activity, lightning, photochemical reactions in the atmosphere, and found that none of these mechanisms could plausibly account for the observed phosphine concentrations. The biological hypothesis was not claimed as the answer. It was left on the table as a possibility that could not yet be ruled out. The announcement sparked immediate and intense scientific debate. Other research teams re-examined the data. Some argued the phosphine signal was weaker than originally reported, a processing artifact or data uncertainty, rather than a strong detection. Others argued the signal was real, and the mystery of its origin remained unexplained. As of the most recent research, the question has not been resolved cleanly. There is ongoing disagreement about the strength and reliability of the detection. But here is the critical point that often gets lost in the back and forth about data quality. The disagreement is about how much phosphine is there, not about whether phosphine should be there at all. Even the researchers who argue the signal was overestimated do not claim that phosphine in the Venus atmosphere is explained. The chemistry of Venus's atmosphere is not supposed to produce phosphine in detectable quantities from known non-biological sources. That is the baseline. Whatever is going on, it requires an explanation that current models of Venus atmospheric chemistry do not fully provide. And the location of the detection matters enormously. The phosphine was detected at approximately 34 miles altitude, which overlaps directly with the altitude range, where temperature and pressure conditions are at their most manageable. The same altitude where the HAVOC concept proposes human habitation could occur. The same altitude where scientists have noted that droplets of water, or acidic solutions containing water, might theoretically exist in the cloud chemistry. The altitude where, if life were going to exist anywhere on Venus, it would most likely exist. Some scientists have proposed a genuinely extraordinary hypothesis that microbial life, if it exists on Venus, may have evolved in the cloud layer itself, not on the ancient surface, which may have been habitable billions of years ago, but actually in the atmosphere, where the conditions are less immediately lethal. Microbes that live their entire lives floating in clouds of sulfuric acid, using the chemistry of that environment as their energy source, reproducing and dying in an aerial ecosystem with no connection to any surface. This is not the kind of hypothesis you expect to find in serious scientific literature, and yet it is there. Because the phosphine data, whatever its exact strength, has given researchers a reason to take it seriously. No conclusion has been reached. No confirmation of life on Venus exists, but the question is genuinely open in a way that it was not before 2020. And the implication is significant. The most hostile major body in the solar system might be inhabited, not on its surface, not by anything complex, but inhabited nonetheless. The universe keeps refusing to be simple. Venus is refusing to be simple. And I think that is worth paying attention to. I want to talk about Earth now, because everything we have learned about Venus in this video has been building towards something that I think is the most important part of this entire conversation. Venus is not just interesting as a scientific curiosity. Venus is not just a destination for future exploration. Venus is a data point, the most comprehensive, most detailed, most undeniable data point in the entire solar system about what happens when a planet's climate system crosses a threshold it cannot come back from. Let me walk you through the deep history of Venus to make this clear. Approximately 4.5 billion years ago, Venus and Earth formed from the same cloud of gas and dust that surrounded the young Sun. They condensed at similar distances from the Sun. They accreted similar materials. They formed into planets of nearly identical size. Venus is 95% the diameter of Earth and 81% the mass. They likely had similar initial compositions, similar densities, similar internal structures. The early Sun was significantly less luminous than it is today. Young stars are cooler than mature stars. This means that 4 billion years ago, both Venus and Earth received less solar energy than they do now. The conditions on young Venus may have been significantly more temperate than they are today. A scientific paper, published in 2016 by Michael Way and colleagues at NASA's Goddard Institute for Space Studies, used climate modeling to simulate early Venus. Their models suggested that, depending on the initial rotation rate of Venus and the distribution of land and ocean, Venus may have maintained surface liquid water for up to 2 billion years. 2 billion years of potentially habitable conditions on Venus. On Earth, life established itself in liquid water within roughly 1 billion years of the planet's formation. Possibly sooner. The timing is not precise, but life is ancient on Earth. If Venus had liquid water for 2 billion years, the question of whether life had time to establish itself there is not obviously answered by the negative. Then something happened. The exact trigger is debated among planetary scientists. The leading hypothesis involves the gradual increase in the Sun's luminosity as it aged. As the Sun grew brighter over geological time, Venus, being closer to the Sun than Earth, received more and more solar energy. At some threshold, the temperature on the surface rose enough to begin accelerating ocean evaporation. Water vapor is itself a potent greenhouse gas. More evaporation meant more water vapor in the atmosphere, which meant more warming, which meant more evaporation. A feedback loop. On Earth, this feedback is limited by the carbon cycle, the process by which carbon dioxide is absorbed by rocks, by the ocean, by biological life, and cycled back into the atmosphere at a rate that keeps the greenhouse effect from running away. The carbon cycle on Earth is a thermostat. It keeps our planet within a range that supports liquid water. Venus lost that thermostat, whether because it lacked the biology that drives Earth's carbon cycle, or because the feedback loop moved too fast for geological processes to compensate, or because some other factor disrupted the balance. Venus's climate entered a runaway mode. The oceans evaporated. The water vapor amplified the greenhouse effect. The surface temperature climbed past the point where oceans could reform. The water in the atmosphere was eventually broken apart by ultraviolet radiation. Hydrogen escaped to space, oxygen bonded with surface rocks. The oceans were gone permanently. Volcanic outgassing continued to pump CO2 into the atmosphere, with nothing left to absorb it. The greenhouse effect stabilized at its new, catastrophic equilibrium, 867 degrees, 92 atmospheres, forever. That process took hundreds of millions of years. It was not fast by human standards. But it was irreversible. Once Venus crossed that threshold, there was no coming back. The feedback loops that had destroyed the temperate climate were self-sustaining. The new equilibrium was stable in its own way, just completely incompatible with liquid water, with organic chemistry, with life. Now, here is where I ask you to sit with something uncomfortable. Earth is currently in a period of rising CO concentration in its atmosphere. The concentration of CO2 in Earth's atmosphere has increased from approximately 280 parts per million in the pre-industrial era, around the late 1700s, to approximately 422 parts per million today. That is a 50% increase in CO2 concentration in less than 300 years. The Earth is not going to become Venus. I want to be very clear about that, because accuracy matters. The feedbacks involved in Earth's climate system are different from the feedbacks that operated on Venus. Earth's position relative to the Sun is different. Earth's atmospheric starting point is different. Earth's carbon cycle has more active components. The scientific consensus is not that Earth is on a path to Venusian conditions on any human, relevant timescale. But here is what Venus absolutely and unambiguously demonstrates: planetary climate systems are not infinitely stable. They are not infinitely self-correcting. They have thresholds. And when a sufficient accumulation of greenhouse gases reaches a sufficient concentration, The feedback loops that amplify warming can outpace the feedback loops that dampen it. When that happens on a sufficient scale, the results are permanent. Venus does not argue for a specific climate policy. Venus does not vote. Venus does not have an opinion on what governments or industries or individuals should do. Venus just exists 40 million miles away at closest approach, with an 867-degree surface and 92 atmospheres of pressure, as the physical, observable, irrefutable answer to the question, what is the endpoint of an unchecked runaway greenhouse effect? That answer has been sitting in our sky, visible to the naked eye, for as long as humans have existed. We finally understand what it means, and the fact that we understand it, because of the Venera program, because of Mariner, because of Magellan, because of every spacecraft that has ever been sent toward Venus, is one of the most genuinely important things that space exploration has given us. Not just the view from the outside, the data from the inside. Humanity has not landed anything on Venus since 1985. For 40 years, the surface of Venus has been visited only by orbiters, spacecraft that circle above those clouds and look down without descending. The Magellan spacecraft, launched in 1989, mapped 98% of the Venus surface using radar imaging during its 4-year mission. The European Space Agency's Venus Express orbited from 2006 to 2014 and returned extraordinary data about the atmosphere and chemistry. Japan's Akatsuki spacecraft entered Venus orbit in 2015 and is still operating, studying atmospheric dynamics. But the surface, that dark, basaltic, furnace-hot surface that Venera 13 photographed 40 years ago, has not been visited since. That is going to change. NASA has approved 2 missions to Venus as part of its Discovery program. DVNCI, the Deep Atmosphere Venus Investigation of Noble Gases, Chemistry, and Imaging, is planned for launch in the late 2020s. DVINCI will send a probe descending through the Venus atmosphere, sampling the chemistry of each layer as it descends, and taking high-resolution images of the surface during the final portion of the descent. The probe is not designed to survive the surface. The science happens during the descent, not after impact. Veritas, Venus emissivity, radio science, INSEAR, topography, and spectroscopy, is a follow-on orbiter mission designed to map the Venus surface in far greater detail than Magellan achieved, using modern radar imaging technology that has advanced dramatically since the early 1990s. Veritas will also look for evidence of current volcanic activity, which recent research suggests may be ongoing. The European Space Agency has its own Venus mission called Envision, currently planned for the early 2030s, which will complement the NASA missions with additional atmospheric and surface measurements. These 3 missions, if they proceed on schedule, will represent the most comprehensive investigation of Venus in history. The data they return will fundamentally reshape our understanding of the planet. The surface geology, the atmospheric chemistry, the history of water, the question of current volcanic activity, and potentially the phosphine mystery. And beyond those missions, the HAVOC concept, the floating airship habitat, remains on the table as a serious future possibility. It has not been funded. It has not been moved into active development. But the science behind it is sound, and it has been presented at serious aerospace engineering conferences by people who know how to build spacecraft. It represents a genuine option for human presence in the Venus system within the next several decades. There are also private ventures beginning to look at Venus. Rocket Lab, the aerospace company, has announced plans for a small private mission to the Venus atmosphere to search for signs of life. If that mission proceeds, it would be the first private interplanetary mission in history, and the first mission specifically designed to search for biological signs in the Venus cloud layer. the next 15 years of Venus exploration, if these missions proceed, will likely tell us more about the planet than everything we have learned in the previous 60 years combined. The technology available to modern spacecraft, the sensors, the imaging systems, the computing power, the communication systems, is in a completely different category from what the Venera program had access to. What Venera 13 accomplished in 127 minutes of surface operation with 1982 technology was extraordinary. What a modern instrumented probe could accomplish in the same time would be something else entirely. Venus is coming back into the center of the conversation. After decades on the margins, treated as the difficult, dangerous, expensive option while Mars got all the attention, Venus is being recognized again for what it is. The most scientifically important planet in the solar system. The one that can teach us things about planetary climate, about habitability, about the history of rocky worlds that Mars cannot. The one that is closer to us. The one that is, in a very specific and strange way, the most Earth-like destination in space if you are willing to float in its clouds rather than stand on its ground. I want to end this video the way it started, with that light in the evening sky. Tonight, if you go outside after dark, and I genuinely want you to do this after you finish watching, you will likely be able to find Venus. It is almost always the brightest thing in the sky after the moon. It sits close to the horizon, either in the west after sunset or in the east before sunrise, depending on where it is in its current orbital cycle. You will know it because it does not twinkle the way stars do. It glows, steady and brilliant, like something that is certain of itself. When you look at it tonight, I want you to hold in your mind everything we have covered. You will be looking at the planet that may have had oceans 2 billion years ago. The planet that may have had conditions capable of supporting life for longer than it took life to get started on Earth. The planet that somewhere in its deep geological history crossed a threshold and began a process that took hundreds of millions of years and ended with a surface temperature that melts lead and an atmospheric pressure that would crush a nuclear submarine. You will be looking at 70% reflected sunlight bouncing off sulfuric acid clouds that are thick enough to hide the entire surface completely from any telescope ever built. The beauty of Venus from this distance is almost entirely a reflection. It is giving you back light that belongs to the sun, filtered through chemistry that would destroy you. You will be looking at a planet where Soviet engineers sent 18 spacecraft over 23 years, and the very best of them survived for 2 hours and 7 minutes. Where the instruments they sent back color photographs that remain the only color images ever taken on another planet's surface, and that are now 40 years old, with nothing to replace them. You will be looking at a planet where, at 31 miles altitude, the conditions are close enough to Earth's that serious aerospace engineers have written technical papers about floating cities, where something in the cloud layer is producing a gas that science cannot fully explain with known non-biological chemistry, where the question of whether anything is alive, right now, in those acid clouds, cannot be answered with certainty in either direction, and you will be looking at a warning. Not a catastrophic, immediate, apocalyptic warning of the kind that tends to get attention. A slow warning, a geological warning. A warning written in 4 billion years of planetary history in the language of atmospheric chemistry and feedback loops and thresholds that, once crossed, do not uncross. Venus is what happens at the far end of a greenhouse effect that runs away from itself. Earth is not Venus. Earth is not going to become Venus on any timescale that is relevant to any human alive today or any foreseeable generation. But the physical mechanism that made Venus what it is, The accumulation of greenhouse gases, the trapping of heat, the feedback loops that amplify warming. That mechanism is not unique to Venus. It is the same mechanism, operating at a different point on the same curve. Venus got there first. Venus got there by a combination of its proximity to the Sun and whatever happened in its ancient climate that triggered the runaway process. It has been there for hundreds of millions of years, and it will be there, glowing in our evening sky, for billions of years more, long after whatever story humanity tells about its own relationship with its own atmosphere has reached its conclusion. That light in the sky is patient. It does not have opinions. It does not have intentions. It has been burning steadily in human skies since before Homo sapiens existed, through every civilization that has ever risen and fallen on this planet, and it will still be there long after we are gone, regardless of what we do. What we choose to do with the lesson it offers. That is our business. Venus has already had its story. We are still in the middle of ours. Go outside tonight. Find it in the sky. And think about what you now know that most people walking past you on the street do not. That changes something about how it looks. I promise. All right. We just spent an hour on Venus together. We went from that beautiful light in the evening sky all the way down to the surface, where lead melts and Soviet spacecraft survived for 2 hours at best. We floated in the cloud layer, where NASA engineers want to build airships. We followed the chemistry of a gas that should not be there. We watched a planet destroy itself over geological time and thought about what that means for the world we are standing on. If you made it all the way here, genuinely, thank you. This kind of deep, careful, hour-long dive into a single subject is not for everyone. It is for people who want to actually understand things, not just feel like they did. And the fact that you are still here tells me something about you. This is what Brain Twist is for. Every week on this channel, we take something that deserves more than a headline. A planet, a phenomenon, a discovery, an idea, and we actually go into it. Not a surface pass, not a highlight reel, the real thing. If you want more of this, subscribing is the only way to make sure you see it. The YouTube algorithm is genuinely unpredictable, and the only reliable way to stay connected to this channel is to subscribe and turn on notifications. It takes 5 seconds, and it means the next time we do something like this, you will actually find it. If this video gave you something, if it changed how you think about that light in the evening sky, if it made Venus feel real to you in a way it did not before, share it with one person who would appreciate it. That is how this kind of content finds its audience. Not through advertising. Through people who found it valuable deciding to pass it on. Drop a comment telling me what part of this landed hardest for you. Was it the Venera program? The HAVO's floating city? The phosphine? The comparison to Earth? I read everything, and the comments on these deep dive videos are genuinely some of the best conversations on this channel. Next week we are going somewhere else. Somewhere equally strange, equally underappreciated, equally full of things that most people have never thought about. I will see you there. Venus is still out there tonight. Go find it.